Alright, Bismillahirrahmanirrahim. Okay, as promised, this is the video that I want you guys to try using source transformation. And then I said that you can try, but I know that some of you having difficulties and then unable to solve this question. So I said this is in fact level 5 question for source transformation. Superposition, it is very straightforward, very easy, but if you want to do source transformation, you really have to understand the fundamental. Okay, so I'm just gonna highlight a few pointers so that along the way you get the important points that you need to know as we tag along in solving this question using source transformation. So number one, V0 is in fact the voltage across 20 kilo ohm. That's the first point that I want you guys to remember. Point number two, this one here is one essential node. Okay, that's point number two. The most important and critical point in solving this question is also this, which is the current of I phi over here. This I phi is used for this dependent current source. Okay, so the current of I phi is basically only until this path. So what it's saying is you cannot manipulate 5 kilo ohm, okay, because it will affect the value of I phi, hence it will affect the value of the dependent current source. So hence the reason why this question is level 5 if you are using source transformation. Okay, I hope that gives you some idea. Okay, all right, now I'm just going to turn off that one. So now you're going to start with solving the circuit. So number one, I would definitely resketch the circuit so that I could give you a clearer explanation later on. So now the next bit I want to do is the first source transformation, because remember source transformation first is you do anything that's obvious. Obviously there's nothing in series that I can solve, or anything in parallel that I can solve. So I know that I have to do transformation. So don't be shocked that I'm going to do the first transformation here. Okay, why? Because I need to get I phi. Okay, I need to find I phi in order for me to be able to solve for V0. Okay, hence as mentioned, this is a level 5 question. Right, so then my next transformation will look like what? So after I transform, when there is a current source in parallel with a resistor, I'm not talking about the 5 kilo ohm. I should write things better, right? So I transform it to become a voltage source in series with the voltage source. Voltage source in series with resistor. Here is 20k ohm, and this one here again, V equals to IR, the principle of Ohm's law. My value I is 7 milli, and my R is 20k. That gives me 140 volt. Okay, and then I'm going to put this 35. Okay, so far so good. All right, now I need to clarify. So where is this V0 then? V0 is the voltage from this essential node to this essential node. Okay, so now where is it? So now it is here. From here until here, this is your V0. Don't worry, just stay with me. Okay, and let me just copy that bit. Alright, after that, then what do I do? Remember, after transformation, you must be able to reduce. After transformation, you must be able to reduce. So what do you do? So I know that straight away I can see that the voltage source, they are in series so I can add it up. Okay, now it looks like what? So my next circuit, can I just squeeze over here? I think I could. Now what's the value here? Okay, these two here, these two voltage source, okay, they are of the same sign, so I know that it is just 140 plus 35. It gives 175 volt. Okay, now after that, there's nothing else that I can do, so I know that I should be able to transform. Next step, transform again. So what am I transforming? This time I'm transforming this. When there is a voltage source in series with a resistor, I can transform it to become a current source in parallel with that resistor. So now my circuit looks like what? Just going to sketch it here. Can I squeeze it? Yeah, maybe I make this one shorter. Alright. And then I transform it to become a resistor 20k and a current source. Now, how to know the direction? The arrowhead. So you just have to assume that, okay? I'm just gonna imagine that this one is here and this one is here. So it is basically plus, minus, and a resistor here. Okay, so if in the case that you cannot see, okay, so I'm just sketching that there. That means that the current is flowing to the left. So what is my I? I equals to V. Oh, my V is so ugly. V over V over R. V over R. For some reason, why are you so jagged? My V is 175. Oh, why? What happened? Oh. Aduh, I don't know what I didn't purposely do, nor my hands is not shaking. For some reason it goes jagged. I don't know why. Okay, what's the value over there? 175 divided by 20k gives me 8.75 milliampere. Alright, now remember, each time after we transform, we should be able to reduce. Okay, let me just copy this. Alright, then I know that I need to reduce. So what am I reducing? I know that I mentioned that I cannot touch I-Fi here because the dependent current source depends on I-Fi over there. So I know that I want to add the two current sources together. Okay, so I'm just going to maintain the direction of the current going in this direction. Why? Because I want to get I-Fi. Okay, if you remember what I teach in class, okay, I want it to, so that it's easier for me to see I-Fi in this direction. Remember current flow? Wee, choo, wee, choo. Okay, that's the only reason. So I added two current, 5 kilo ohm over there. That's my 20 kilo ohm. What is my value here? Okay, current source in parallel can be added up, but they are in different directions. So I know that it is 8.75 milli minus 5 I-Fi. Alright, okay, so far so good. Okay, I'm just going to bring this again to the different circuit so that once I have done that, can I get I-Fi? Remember, I have to get I-Fi in order for me to be able to get V0. Can I get I-Fi? The answer is yes. How? By using current divider. Alright, I just have to write slowly. I5 is actually the opposite resistor over total resistor multiplied by the source. 8.75 milli minus, sorry, I have to do it like this. That's what happened when you didn't plan. Oh my goodness. No, it doesn't look right. No, I need to. There you go. So by current divider, my I5 is in fact opposite resistor is 20 kilo ohm over total resistor is 20 kilo ohm plus 5 kilo ohm multiplied by the current source 8.75 milli. Ya Allah, why suddenly so beautiful then the M started to become ugly? Something is wrong. Milli minus 5i5. Alright, this is maths. What I do next, I cross multiply, then I get 25 equals to, plug into your calculator. Okay, you rearrange it. Then you get I5 equals to 175 over 125 kilo ohm. That's kilo, not kilo ohm. Then you will get 1.5 milliampere. Alright, so you notice that we haven't actually go beyond chapter 2. So after getting I5, what do I do next? Alright, now you can go back to your circuit. Hey, I skipped this page. Oh no. Now I'm coming back to this circuit. Alright. So let me just copy that circuit again. So coming back to this question again. Alright. So after I get my I5 we got just now from our calculation, from current divider, we already established that I5 equals to 1.5 milliampere. So after getting this, what is next? What is next is basically we can calculate our V0. How? By getting our I5, we can get the current, the one in blue, we can get the current here. Basically the current in this path over here. Alright, what is the value? The current, let me just call I0, okay, equals to 5i5 plus I5. Do you see this? Let me just change the current. Oh, it's raining so heavily outside. So the current here will enter and leave the yellow one. So therefore, V0 is what? V0 is minus 140 plus 20k multiplied by 6i5. Okay, what is 6i5? Basically 140 plus 20k. 6, my I5 is 1.4 milli. Okay, then you will get minus 140 plus 168 equals to 28 volt. There you have it. By using source transformation, these are the steps to solve question 4.3. Yay!